This is video on friction. This is the fifth video. This is the fifth video in the series. Now, first video of the series deals with the basics of frictions, and remaining videos deal with problems of frictions. Now, this particular video, video 4, deals with what is called wedge friction. And in order to demonstrate what exactly the wedge friction is, we have taken this problem which says the block A, as shown in the figure, is to be raised by a force by forcing the wedge B under it. So this wedge B we are forcing under it. The angle of friction is mu equal to 15 degree and is same for all surfaces in contact. We have to determine the force P which is necessary to start the wedge under the block. The block and the wedge have negligible weights. Now, a little practical application of this is like this. See now, this 5000 Newton weight, let's say, is kept on a block A and it is to be raised. It is to be raised up. Now, for raising up, it is usually easy to hammer something below it. You know, these are usually, like, practical application is a heavy machine, and these are wooden wedges, very lightweight. Now, for the demonstration purpose, we have exaggerated this slope to 20 degree to explain the principle, but this slope can be as less as 5 or 7 degree. So see, as you drive this wedge under it, this A moves up, and it's much easier to move the weight up rather than directly making arrangement of lifting. That's the practical application. Okay. Now what we do is, see, mu is equal to 15 degrees. So, the angle of friction is 15 degrees. So, the coefficient of friction is tan 15. And what we'll do now is we will draw free bodies of all these bodies, taking x-axis as horizontal and y-axis as vertical. Okay. So, let's move this up just for the clarity purpose, and then let's concentrate on wedge B. The reaction R1, this force P, friction, see, tan 15 is 0.268, so friction is mu R. Then this reaction R3, then friction here will be down. Then reaction on B from A, and here reaction on A from B, both via R2, and here the corresponding friction directions. This covers all the forces. Now let's study it a little bit. Let's look at wedge B. First of all, you have noted that weight is neglected because these are supposed to be very light compared to this 5000. Now this wedge B is trying to move towards right because of P, and therefore at both surfaces, this surface and this surface, frictional force will oppose this tendency, and that will be corresponding mu R, 0.26 at R1 here, 0.26 at R2 here. Now direction of this R2 will be perpendicular to this plane which is inclined at 20 degree. And when we come to body A, these friction and these reaction directions are reversed. This R3 is perpendicular to vertical surface, and see, the block A is trying to move up under this P, and therefore friction is down here, and this 5000 is the weight which acts down and which we are trying to lift. Now, as already mentioned, x-axis will be horizontal, y-axis will be vertical, and we'll try to write sigma fx, sigma fy for each of them. Let's take wedge B, the lower block, and let's write sigma fx. P minus this 0.268 R1, that is here, and then component of this 0.268 R2 in x direction. See, the angle here is 20, so it is cos 20. And this R2 also will give you component in x direction. Angle it makes with vertical is 20, so with horizontal it is 70, and this will be R2 sin 20. the horizontal component of R2. That is equation 1. Now similarly, equation 2 for y direction will be R1 minus this R2's vertical component R2 cos 20 and plus 0.268 R2's vertical component, that will be 0.268 R2 sin 20. So this was sigma fx and sigma fy for wedge B. Now we write sigma fx and sigma fy for wedge A. So sigma fx is R3, then 0.268 R2 and cos 20 and minus R2 sin 20. See, these two is are in this direction and R3 is in opposite direction. So we have this sigma fx, and sigma fy is R2 cos 20, 0.268 R2 sin 20 minus 5000 and 0.268 R3. Now mind you, here the motion is trying to be upward, so these forces, upward forces are positive and downward are negative. And here for block A, see, because block B tries to move towards right, block A tries to move towards left, and that's why here this R3 is positive, rest of them are negative. So we have sigma fx0, sigma fy0 for upper block and lower block. Now by solving all these four equations, we'll get our P. See, solving 3, we get relation between R3 and R2. Using that and solving 4, we will get R2 and R3 numbers, and solving 2, substitute R2, R3, you will get your R1, and using R1 and R2 in equation 1, we'll get the P. We will get the P, the final answer which was needed. So we have managed to solve for P using this, and this lower body is wedge shaped, so this is called wedge friction, and the speciality of this is wedge weight, and in this case even upper body weight is neglected. Sometimes 5000 is clubbed with upper body and together the weight may be 5000, but wedge weight is surely very less than the what you are trying to lift. So this is 5960 force is needed. Mind you, in comparison with 5000, though this number value is same, I mean equivalent, but driving it horizontally is much easier than trying to lift something in a vertical direction. That's why these applications are of practical importance. Thank you.